Hello and welcome to this introduction to Factsheet 18 on the embodied carbon dioxide equivalent of UK cement, additions and cementitious material. My name's Diana Casey and I'm Director of Energy and Climate Change at the Mineral Products Association and author of Factsheet 18. In this webinar, I'm going to give a bit of an introduction to the UK cement sector to highlight where emissions arise and what is being done to reduce these before going into more detail on some of the data behind Factsheet 18. So in the UK, we've got 5 companies producing Portland cement at 11 kiln sites across the UK as shown here. To produce cement, calcium carbonate in the form of limestone or chalk and clay raw materials are quarried and crushed to the required size before being homogenised to the correct chemistry. The materials then enter a preheating phase that generally utilises waste heat from the kiln. Following this, the materials are heated to high temperatures of around 1,450 degrees. After heating, the resulting clinker is cooled before being blended and ground with other materials to produce cement. The largest proportion of emissions arise in the production of the intermediate clinker product. Heating calcium carbonate-based raw materials releases carbon dioxide, and this generates around 70% of the emission associated with clinker. These are known as process emissions. The remaining 30% is attributed to the combustion of fuel. In producing cement, there are also emissions associated with the large amount of electricity consumed in quarrying, crushing, blending and grinding, and emissions associated with transport. The cement sector has made considerable progress in reducing emissions as shown in this chart. The orange line shows an absolute emissions reduction of 51% since 1990, and the blue bars show an overall reduction in emissions per tonne of cement of 28% compared to 1990. This decarbonisation has been brought about by millions of pounds worth of investment in fuel switching away from fossil fuels, reducing the clinker content of cement and investment in the most efficient plant technology. Now, we often hear that cement accounts for around 7% of global greenhouse gas emissions, but in the UK, cement accounts for only 1.5% of total UK greenhouse gas emissions, and the UK has the second lowest cement use per capita in Europe. MPA and its members are involved in a number of innovation projects looking at how deeper levels of decarbonisation can be achieved. These include research into new low-carbon cement, fuel switching to innovative technologies including high proportions of biomass, hydrogen and electrical energy, and carbon capture and use or storage. As the UK looks at how to achieve net zero by 2050, it's also important that the significant downstream benefits of concrete are taken into consideration. This is where the use of concrete can help lower emissions, for example through recarbonation, which is the process where concrete absorbs carbon dioxide from the atmosphere throughout its lifetime, at end of life and in any secondary use. And thermal mass, where concrete can be used in well-designed buildings to reduce the energy required for heating and cooling. These operational benefits of concrete must be considered alongside the embodied emissions set out in the fact sheet of the cement. All the knowledge of the emissions associated with cement and concrete and the techniques that will be required to reduce them have enabled a detailed model to be produced and a net zero roadmap to be launched. This roadmap sets out how the cement and concrete sector can reach net zero through reducing emissions associated with the manufacture of these vital products, and even go beyond net zero when the downstream benefits of carbonation and thermal mass are taken into consideration. More information on the roadmap is available on the UK Concrete website. So now back to Factsheet 18. So Factsheet 18 is a cradle to factory gate analysis of all greenhouse gas emissions associated with UK cement, additions and cementitious material. It is the most accurate and complete data set available for cementitious materials because the data is sourced directly from UK plants and the majority of the data, over 90%, is independently verified. MPA's aim in producing it is for it to be freely available to all for use in informing carbon footprinting in the concrete supply chain. The data also underpins other guidance documents produced by MPA, including specifying sustainable concrete. The fact sheet covers not just emissions of carbon dioxide, which make up the majority of the emissions, but also non-carbon dioxide greenhouse gas emissions like methane and nitrous oxide. These emissions are converted into carbon dioxide equivalent emissions, which hopefully explains the reference to equivalent in the title of the fact sheet. The data contained in the fact sheet includes a breakdown of the components of cement and the embodied emissions of different cement types. I'm not going to go through each of these numbers now, but I am going to provide an overview of the data used to produce these values. The main constituents of cement are clinker, the intermediate product that I mentioned earlier when discussing the manufacture of cement, gypsum or calcium sulfate, minor additional constituents or MAC, ground granulated blast furnace slag, a byproduct from steel manufacture, pulverised fly ash from the coal-fired power generation, and limestone fines. I've provided an example here for CEM 1, which is made up of around 91% clinker, 5% gypsum, and 4% MAC. But another example might be a CEM 2 cement, which could be made up of clinker, gypsum, limestone fines, and MAC, or a CEM 4 cement made up of clinker, gypsum, fly ash, and MAC. And I just wanted to mention here the cement standard EN 1971, titled Cement Composition Specifications and Conformity Criteria for Common Cement. This standard provides the composition of the various common cements, and it states that for CEM 1, for example, the clinker content is 95 to 100%, with minor additional constituents, or MAC, making up the remaining amount to 100%. However, this composition excludes any gypsum, which usually makes up around 5% of the final cement composition. Therefore, when we take the final cement, including the gypsum, clinker makes up around 91% of the final cement as shown here. This can often cause confusion, so hopefully I've provided some clarity. The majority of emissions associated with cement arise from the production of clinker, so I'm now going to go through these in some detail and explain where the data in the fact sheet has come from. I'll then mention briefly where the data on the other cement components has been taken. So emissions associated with the production of clinker arise from the combustion of fuels, the calcination of raw materials, also known as process emissions, as mentioned earlier, the transport of fuels, raw materials, and imported clinker, emissions of other non-carbon dioxide greenhouse gases, such as methane and nitrous oxide, or N2O, and indirect emissions associated with the generation of electricity that is consumed in the manufacture of clinker. So starting with the combustion and calcination emissions, these together make up 93% of the emission associated with clinker production. These emissions are covered by the EU emissions trading system, which is detailed regulations setting out how emissions must be monitored, reported, and verified by a third party. Emissions are verified to a very high level, with verifiers required to visit the site and ensure all sources of emissions and their level are correct. Transport emissions were calculated following a detailed data collection exercise from all UK plants. The data on materials, fuels moved, distance and transport mode were converted to emissions of carbon dioxide equivalent using UK government life cycle emission factors that are published on the government website. Now, over 99% of greenhouse gas emissions associated with the production of cement and clinker are carbon dioxide. However, MPA wanted to be transparent in its embodied carbon dioxide equivalent emissions, and therefore the two largest sources of non-carbon dioxide greenhouse gas emissions were included in Fact Sheet 18. This covered emissions of methane and nitrous oxide. These were converted using global warming potential factors produced by the International Panel on Climate Change, and together these non-carbon dioxide greenhouse gas emissions make up 0.6% of the total emissions from clinker production. Finally, the emissions associated with the generation of electricity consumed is calculated from the electricity consumed in clinker and cement manufacture and converted to carbon dioxide equivalent emissions using the UK Grid Average Conversion Factor that's published by the UK government every year. This does generate an overestimate of emissions associated with electricity consumption because almost all UK cement producers purchase electricity through green tariffs, and this renewable electricity has no carbon dioxide emissions associated with it. So that concludes a run-through of the emissions associated with clinker production and covers the majority of emissions associated with cement. In terms of the embodied carbon dioxide equivalent associated with the other constituents of cement, these are shown here. There are two sources of gypsum used in cement: recovered gypsum from waste such as plasterboard and natural gypsum. The data on embodied carbon dioxide for this was sourced from British Gypsum, with an uplift added to include the transport of the materials to UK cement plants. Next, limestone fines, and MAC. Almost all MAC added into UK cement is limestone fines. The embodied carbon dioxide equivalent information for this was sourced from an academic journal publication and was based on research by Heidelberg Cement. Granulated blast furnace slag data is based on an environmental product declaration produced by Hanson, one of the cement producers in the UK, and the fly ash data was provided by members of the UK Quality Ash Association. All the data includes an uplift to cover transport to the cement works. As well as providing data for different cement types, the fact sheet also includes the embodied emissions associated with the weighted average cement. This is an average of all UK cement made at cement works. The weighted average cementitious emissions, which is also included, provides an indication of the embodied emissions of the average cementitious product used in the UK produced concrete. This latter figure recognises that in the UK, many additions of slag, ash and limestone are made at the concrete works and not at the cement factory. It's based on sales data of cementitious materials. So that concludes my quick run through Fact Sheet 18. In summary, there's no other source of embodied emissions information on cement and cementitious materials that is as accurate. The fact sheet is updated regularly to reflect changes in embodied emissions associated with cement manufacture, and this will be particularly important as the sector decarbonises. The fact sheet is free and available to everyone to help inform carbon footprinting of vital cementitious materials. The Fact Sheet 18, along with a range of other fact sheets relating to cement, can be found on the MPA website. The Concrete Centre guidance specifying sustainable concrete can be downloaded from the link shown. And finally, if you have any questions or need any further information on the fact sheet, my email address is shown here. That just leaves me to say many thanks for your attention.